Okay, so what I want to do here, boys, is just go over the types of relations there are, okay, and then the kind of domains that they exist under. So the first of these relations that we're going to consider is what we call a one-to-one function, all right? And that means that each single value from the x maps to one single value for the y. So what I mean by map is, for example, here, if I put x equal to 1, well, there's only one way I can get y is equal to 2 times 1 plus 1, which is equal to 3. And that's the only way I can get 3. If that x value is equal to 1, I get y equal to 3. It's the only way I can get 3, and it's the only time, and it's the only number that x equal to 1 generates, okay? So that's a one-to-one function. The easiest way to tell this is we know a relation. A relation is a function if I draw a vertical line and it crosses only once. We discussed that already. Okay, crosses once. Well, it's a one-to-one function if I also draw a horizontal line and it crosses only once. So vertical line down, once cross, horizontal line across, one-to-one function. All right. Let's consider the next one. The next one is a many-to-one function. Okay, so more than one x value maps to the same y value. So in other words, it's not the best axis, but that'll do. If we consider something like y equals x squared, if we consider the value, say, x equal to 2 and x equal to negative 2, well, if y equals x squared, that point there is the point 2, 4. That point there is the point negative 2, 4. So what we're saying is many x values map onto one y value. So in other words, many being negative 2 and 2. So negative 2 maps onto 4. Positive 2 maps onto 4. Okay? So many x to one y. If we consider our vertical line test, if I do a vertical line, it crosses only once. So yes, it's a function. But if I do a horizontal line, it crosses twice. So it's not a one-to-one function. Okay, it's many to one. All right. If we go to our next relation, plus or minus the square root of x. So positive square root of x is that part of it. And if you like, the negative square root of x is down here. So if I draw a vertical line through here, we can see that it crosses twice. That makes it a relation, okay? But if I draw a horizontal line somewhere, it only crosses once. So in fact, there's one x value, which in this case we'll call it 2. I'll make it 4. There's one x value, and it goes to many y values. In other words, one x value 4, that's equal to plus or minus the square root of x, which is plus or minus 2. So 4 maps onto 2, and 4 also maps on to negative 2. So one x value to many y value. If we have that sort of relation, it's not a function. Remember, it's not a function because it crosses twice. The final type of relation we have is our circle. And we can see here, if I draw a vertical line, it crosses twice. And then if I also draw a horizontal line, it also crosses twice. So it's definitely not a function. And in fact, it's a relation that has many x values mapping onto many y values. So it's a many-to-many relation. All right. So they're the types of functions. So this is the best, I guess, advice we can give you. If you want a function to be one-to-one, draw a horizontal line, and if it only crosses once, well, then it's a one-to-one function. All right. Now, that's why we want to know if a function is one-to-one, because a little bit later on, we're going to look at what we call inverse functions, and we can only work them out if our function is one-to-one. Okay. Let's keep moving through. So let's consider our, we've spoken previously about implied domains. So I'm going to, what if I might split this up into 4 sections. All right, let's consider each graph as they go. So we've spoken previously, if I want to work out the nicest way to sketch these graphs, we know we consider the translations that have taken place. And the first piece of advice I can give, let's always rewrite our functions so that the coefficient of x is 1. So in this case, if we take 3 out the front, I get x minus 3, okay? So that means that my standard graph here, which I might just do in black, there's my root x graph. It's been shifted 3 units across to the right. And so it looks like that. But in fact, what we might do is we'll consider the effect of the other 3 has. So instead of giving it the same sort of rate of increase, we'll make it gets bigger quicker. So it actually goes more like that, okay? So that's what the graph looks like, and that's the point 3. So if we want to consider the domain of this graph, remember, let's use a bit of color coding here. The domain of my graph we'll do in green. So the x values there is from 3 to infinity. The range is always the y values, which is that section, and it's only from those values on. The range is from 0 to infinity, okay? So whilst initially we might think that the graph moves 9 units to the right, we take out that factor of 3 and we see it actually moves only 3 units to the right. So let's consider graph B. So if y equals 1 over 2x minus 3, again, let's write it as y equals 1 over 2 times x minus 3 on 2. All right. So again, let's sketch what we know about the graph. It's hyperbola. So we know it's there and there. We know the asymptotes. Where do the asymptotes occur? The asymptotes occur when my denominator is 0. So we can see that the graph has moved 2 on, oops, sorry. Let's fix that up. It's moved 3 on 2 units to the right. So my asymptote now, okay, is that x is equal to 3 on 2. So then the graph, the horizontal, actually we should put the horizontal asymptote in, shouldn't we? The graph hasn't moved up or down at all. So let's get y equal to 0 in there. My graph hasn't moved up or down at all, which means I'm in the top right and the bottom left. And just to confirm that, let's find that point there. If I put x equal to 0 into there the easiest way, I get y equals 1 over 0 minus 3, which equals negative 1/3. So 0, negative 1/3 is the intercept. Okay. So there's my graph again. Instead of it looking like that it's moved 3 units to the right, it's actually moved 3 on 2 units to the right. All right. So let's follow the same principle here. So what do we need to do? I want to write this as y equals the square root of -2 comes out the front. So that's going to make that a positive x, and that makes that a -3 on 2. Multiplying to check, -2 times -3 on 2 is +6 on 2, which is 3, minus 2x, so it's the same thing. So again, instead of it moving, so let's rewrite it so in the form we're used to, y equals the square root of -2 outside of x minus 3 on 2. So what do the different things do? 3 on 2 to the right, the negative sign in there flips it, rotates it about the y-axis, okay? And if we weren't too sure about that, let's come down here and think about the domain of this function here. So we need 3 minus 2x to be greater than 0 because I can't get the square root of a negative number. That means 3 has to be greater than 2x, which means 3 on 2 is greater than x. So x is less than 3 on 2. So if I want to sketch this graph, I know the whole thing has moved 3 on 2 units to the right, so we're starting there. But instead of going this way, where I'm going to get the x values are bigger than 3 on 2, I have to go this way. Because here, it says the x values are less than 3 on 2. And if I want to make sure of that, the y-intercept, that means x is equal to 0. Substitute that in, y equals the square root of 3. So that point there is root 3. All right? Now, I've just remembered I didn't answer my domain and range components. So let's consider our domain for part B. The domain is the x values. What x values can I have? Everything except for that asymptote. Yeah? So the domain is all the values except for 3 on 2. And if I do the same thing here, my range is the y values, everything except for that value there, which is at y equal to 0. So if I put the range is all the values except for 0. Okay? Come in here. My range is from that point there, all the x values that way, which corresponds to that. So my domain is, what do I need? I want from -infinity up to 3 on 2, including 3 on 2, so I'll put a round square bracket on 3 on 2. My range is the y values. My y values start here and head up. So the lowest y value is 0. The highest y value is positive root 3. Oh, my bad. It's positive infinity. Geez, I nearly made a mistake here, boys, mate. Let's get rid of that. Now it's positive infinity because the graph continues upwards, doesn't it? It goes all the way up here. All right. Question 4. What are we doing there? We've got y equals, what does y equal? 1 over 2x minus 1 plus 2. Let's again write it as 1 over 2 x minus a half plus 2. So we can see movement that's happened here. Plus 2 means everything's moved up 2 units. So we've got y equal to 2. And in here means it's moved to the right half a unit. X equals a half. So I've got our asymptotes in there. There's no negative signs anywhere, so I know the graph fits in that corner there. And it fits in here somewhere, I guess, in this section here. So I need to find an intercept really before I know exactly where it crosses. So what if we find, well, the y-intercept if I put x equal to 0, what do I get? I get 1 over 0 minus 1 plus 2, which equals negative 1 plus 2, which is 1. So it goes to the point 0, 1. So I know my graph goes like this now. Yeah. I want to find the x-intercept just to confirm. Put y equal to 0. I get 0 equals 1 over 2x minus 1 plus 2. Just in here. Negative 2 is equal to 1 over 2x minus 1. Negative 2. Multiply. And then divide. So then I've got to add 1. I'm going to run out of room. So I'll get 2x equals negative a half plus 1, which is a half. Divide by 2, x is equal to a quarter. So that point there is 1/4. Okay? So key things. Biggest thing is let's write the coefficient of x as 1 in all of these kinds of questions. That way we know how big a transformation or translation, left or right, has occurred, and then we move everything else accordingly. All right, good luck.